Okay, let's get started with chapter 5. So let's go through some of these. Determine whether discrete, continuous, or neither. Okay. Time is definitely continuous. Maybe they'll make us do either one. Time could be any number in a certain interval. Okay, number of bald eagles in a country, that has to be discrete because there can't be like a half. Eye color is not numerical, so we don't consider that a random variable. The amount of snowfall. Snowfall could be anything, so we want to go continuous. Could be any value in an interval. The amount of rain too, that could be any number, continuous. Okay, the time it takes for a light bulb to run out, that's continuous. Okay, and here's random variable. A random variable that has a single numerical value determined by chance. It's basically like data, that when data is a number. If it has infinite, it's continuous. Should be finite. Oh, the expected value is the mean. The expected value is the mean, so you need to know that. Okay, now this is called a probability table. Now what we have to do is check to make sure all these are in between 0 and 1, which they are. Now we have to add those up. So I'm going to say yes, but what we really need to do is add these numbers up. So I'm going to add them. And it worked. So yes, it works. Okay, so to find the mean of a discrete random variability probability table, we want to go to the custom calculator. So we need to open this up in the custom calculator. So we go to Stat, Calculators, and down to Custom. Now the values are these x values. So we want to tell that. And the weights are the probabilities. And compute. So 2.5. Okay, the standard deviation is this guy right here, 1.107. So we have to go to 1 decimal, so 1.1. Take note, make sure you understand this notation too. That little funny squiggly thing, that's the standard deviation. Okay, so this is the same exact type of question. So I'm going to leave it up to you guys to add these things, but I'm just going to assume that it's a yes. Oh, maybe it's not. Okay, let's add them up. Sorry. So I'm adding them up. Oh yeah, they don't add up to be 1 because I thought this was 0.63. Yeah, those don't add up to be 1. Okay, they're associated with probabilities. Number of women, TED approach is okay. I think this is right. Let's go with not that. Very nice, easy one. So if they don't add up, you can't do any of this stuff. Okay, so let's assume 40, 70, 80, 42. Okay, I'm just going to say yes. I don't want to add them up. You need to add them up. Make sure they're 1. Okay, good. Now to find the mean, it's the same thing. We want to go to this custom calculator. So let's get out of it here. Just get out of the whole thing. So click on that box, hit that box. I want to go Stat, Calculators, and Custom. Weights are the probabilities. Probabilities are your random variables. 0.894. One decimal, so we'll go 0.9. Okay, how many decimals? One decimal, so 0.8. I'm taking this guy now. Over here. See over here to the right? 0.8. It's actually a highly missed question on something that's really easy to do. Okay, so let's get rid of this StatCrunch. The mean is the expected value. Same thing. Stat, calculator, custom. Variables and values in x. Weights are probability. So the mean is 1.535. And it says one decimal. So I come over here. That's a 3 on the second decimal, so that stays a 5. Try 1.0 there. Okay, so now to use the range of thumb, the range of thumb is you're going to take the mean and then add and subtract 2 standard deviations. If the value is outside of here, right? Because if you're at the mean and you add something, you're going to be like over here. If you subtract something, you're going to be like over here. So this is, we need to find out, is the value over here, the data value over here, or is the data value in here? In here or over here? That's how you tell if something is significant or not. So in here would be not significant. And out here would be significant. Over here would be significant. Anytime you fall away from the mean, that's called significant. Okay, so let's figure this out. So this is how many girls that you could get among 10 children. So there's a lot. So what I'm going to do, stat, I need to get the mean and standard deviation. I'm hitting custom down here. But the random variable would be how many girls they had. So on average, it would be a little over 5. So I'm going to put this for the mu. Oh, it disappeared. I think that's what it was. The standard deviation. So now this goes in here. This thing goes in here. I wouldn't round this. So essentially we're going up 2 of these. You might get away with some rounding, but oh, they asked for lower, I think. Darn it. They asked for lower. Okay, I did the minus here. And I ended up with 1.58, so that's 1.6 because it says round in one decimal. That's what I did. This doesn't make sense, because I put my thing in wrong. Oh, max. Jeez Louise. For some reason I was thinking I said min. It went to plus, not to minus. So when I did that one, I still have it on my calculator, 8.5. There we go. The minimum would be the other one I had, which is 1.6. Sorry about that, I just got backwards. Okay, so if you, I got this 1.6 over here, the mean which was like 5.035, and this max I have 8.5. So now they're saying, is one growth significant? So then you're coming here, you're like, if this is a number line, these are like our cutoffs. One sits over here, so that's a yes. Just read C, because one is below the range that are, all these are not significant. Make sure you have that concept. Okay, so relevant probability is that or above so relevant is 57 or more, which comes out to be 0.097. Okay, so to do significance, you have to compare this number, 0.097, with 5%, which is 0.05. So you have to put them right next to each other. So put that value here, put this. To be out of the ordinary, this would have to be less than, but this is greater than. So it's not less than. Sorry, that's greater than. That's true. So that is more than that, which makes it not significant. That's why I got the is not. For it to be significant, that had to be below it. And that's where the greater than comes in. So make sure you slow this down and read through this one a few times. Okay, getting exactly 4 among 5. Okay. Exactly 4. These are all the exact probabilities. In this table are the exact, so it's just 0.021. 0.021. Okay, so now, if they say 4 or more, what you want to do is add these last two, or if you want, you could just open them up in StatCrunch and let StatCrunch do it for you. Go to your custom calculator again. This is sort of the long way, but this says 4 or more. That's 4 or more. That means this x right here. Look here on the bottom right. Look where my cursor is going. My cursor is going, oh, it disappeared. Up here. That means this x is allowed to be 4 or more. That's why the thing's opening to the left. Wants to eat the x because it could be 4 or more. So 0.027. So they just added these two. That's it. So two ways. You could add the 4 probability and the 5 probability, or you could do it this way that I just did with StackCrunch. So generally when they say 4, we get the relevant probability. So if they said is 4 significant, then we'd find the probability that x is 4 or more. That's just generally how we do it. Because if 4 is out of the ordinary, and you add 5's probability with it, and it's still out of the ordinary, that would mean that 4 is out of the ordinary. Or like if we add something else that we didn't ask for that's more extreme, and it's still low, that would give evidence that 4 is more. So if you look at the, we just got 0.027, that is less than 5%. So this should be a yes. Probably getting 4 was up here is the relevant probability. Okay, what is the which probability is relevant for determining the 4? It's part B, because you do 4 or more. So let's get rid of the A's. So it's definitely not A or C. It's either B or D. Yeah, I don't think it's. I'm pretty sure it's B. Yeah, B. So read B. Stop it. This value is less than 5%. That this number right here is 0.05. So like on a number line, that's below that. You know, like on a number line, if that's 0, this is 0.027, this is 0.05. So this is less because it comes before it. And if this value is less than that value, then we call the thing that the 4 being significant. You have to know that concept. Okay, good. Let's go down here. Where did it go? Okay, I'm going to pause the video. I'll be back. Okay, I'm back. Okay, so determining your binomial. Sometimes I think of binomial, this little acronym. This is success or fail. This is independent. This is finite tries. And this is the probability of success is the same. I'm just going to say yes. They're either going to say yes or no. We're going to assume that everybody has the same chance. There's a finite number because they only has 150. There's not more than 2 possible answers, so I'm going to say yes to that. Okay, I'm going to go ahead and you guys could, oh wait, let me read that. different senators. Okay, yes, okay, so it's definitely no. Okay, so they're going to serve without replacement, so you're not putting the people back in. So once one person gets picked, it's going to mess up your probability. They have to replace for the binomial. Okay, method. They design increase the chance 50 couples give birth to 50. Okay, so it's going to be yes or no, got boy or girl. I think they're all met. Okay, boy or girl. We could assume that they're independent, that, you know, what happens with one family is not going to affect the next. There's 50 babies and the probability should be the same for each one. Okay, good. You have to be good at this. N is how many customers or how many people they surveyed. So there's 5 people randomly picked. That's your N. X is out of those 5, how many successes were there? That's 3. See, exactly 3 of them. So X is the number of successes. P is the probability that they're going to be comfortable. That's 0.31. Q is the complement of P. So if that's the comfortable, this is Q is that they're not comfortable. So you just do 1 minus that. So what I do is I do 3 plus what gets you 9. And then 1 plus what gets you 10. 3 plus 6 gets you 9. And 1 plus 9 gets you 10. So 1, 6, 9. You want to be good at telling those. Okay. Calculating the mean, we did this in class. That's the formula for mean. That's the formula for standard deviation. Okay, so when it says find the mean on a binomial, I'm looking for the n and I'm looking for the p. So soon we selected 40. We need offspring p's or green. Green. So if there's 40 and 75% are supposed to be green, then there should be 40 times 0.75. So 3/4 should be green. That's 30. The standard deviation, I'm doing this. So to find the mean, which we call mu, I just did 40 times 0.75. For standard deviation, I'm going to do 40 times p, which is 0.75, and then q, which is 0.25. So I'm figuring this out right now. We get 2.89, 2.9. Now your numbers might be a little different, but okay, let me check my numbers. Make sure I got it in right. Oh, I put in a 0.25 on an accident. I put 0.7 and 0.3 instead of 0.75. Okay, 0.75, 0.25. Trying to go too fast. Okay, I got 2.7. Okay, so the rule of thumb is mu equals 30. Standard deviation was 2.7. So now we could go up 2 of these and down 2 of those. So significantly low would be 30 minus 2 times 2.7. So 30 minus 2 times 2.7. Get 24.6. And the upper is going to be the same thing. That's the lower. The upper is going to be 30 plus 2 times 2.7. It's the same rule we learned last semester or last test. 35.4. Okay, so now I got the same idea. I got this is my lower, and I got this is my upper. Anything outside of here is considered significant. So they're asking about 9. 9, let's do a number line. So 9's like over here somewhere. These are all okay. These are all like outliers. So I'm just like, hey, 9 is less than that value. That's what I did. Okay, now let's find probability that x is greater than 4. So let's attack this thing. So you're going to use the binomial calculator. The binomial calculator. To do the binomial calculator, you have to know these two things. You have to know how many were surveyed and what's the chance on each person. So we have 9 and our p is 0.65. Okay. Okay, so what we're doing, so we can see the problem. Let's go stat, calculators, and look for binomial. They're in alphabetical order. Binomial. And if you look, they say, hey, what's n? Well, n is how many people we surveyed. P is the chance, which looks like 0.65. Got 2 points there. Okay, so this 9 goes into there, that 9, this 0.65 in here, and now they say fewer than 3. Fewer than, that's less than 4, less than 4. Fewer than 4. Fewer than 4 is 3 or below. So this is it right here. 0.05. 4 decimals, so 0.535. And that 5 should go to a 6. 4 decimals, 4 decimals. Okay. Okay. Now I'm not going to get out of this binomial. I'm just going to keep it up. Okay, there's 10 adults, so we're going to ask 10. And 56 use their cell phone. That's 0.56. At least 4. At least 4. It's 4 or more. At least 4. So they're adding this line right here with this line, with this line, with that line, with that line, with that. We're having for 4 now. 0.99092. Okay, assume adults are going to say 44%. There's 8 with a smartphone. I feel like I'm doing the same question over and over. 8, and there's a 44% chance. That's going to go to a 0.44. Exactly is an equal sign. 5. So 0.1622. 0.1622. So that's the rounding. Okay, only 3 more. Okay, that's the same question we just did. You guys could do that on your own. 81, I've got at least 11. Okay, so let's do this one. So I see that there's an 81% of people need corrective lenses. Let's see, how many people did we look at? We looked at 12 people. And they say, find the probability that at least 11. At least is 11 or more. That means this is the unknown. 11 or more, so I need to change that to an 11. So that means this x over here is allowed to be 11 or 12. And we only asked 12. So that's 0.3. Okay, 0.304. Okay, now I think they're going to be asking if it's significant when this 0.304 is bigger than 5%, so this should be a no. It would have to be small. This would have to be less than 5%. That's 30%. 30% is not small, so that should be no. Okay, see 16%. Regret getting tattoos? It's funny. Okay, I'm looking for how many they're going to ask. How many were in the poll? They asked 5. So this should be 5. So I changed the n over here to 5, and that's 16%. Find the indicate probability. So none. None would be an exactly 0. This means that all 5 were okay with their tattoos. 0.4182. I rounded to 4 decimals. Exactly 1, exactly, I'm over here now. Exactly isn't equal to. So this is like one of the 5 regret it. So 0.3983. Okay, 4 decimals, 4 decimals. A 0 or a 1. A 0 over 1 is less than or equal to 1. Zero or 1 is 1 or 0. 0.8165. Okay, so is 1 statistically low? No. There's the probability. So if they ask for 1, you have to do 1 and you have to add 1 with the 0. 1 or less. 1 or less. At most 1. Okay, so there's one more question after this, but I'm trying to show you this. If they ask for, hey, is 1 significant? So what you have to do is you have to find the probability of 1 or below. And then you have to say, is this less than 5%? That's what they ask. If 1's significant, you have to do 1 and you have to do 0. 1 and everything more farther away. Well, that's a humongous number. That came out to be 81%. That's not significant. I'm not sure about this. Based on survey, okay, so there's 1,000, 1,009. P is 42%. Now they're saying they picked 30. Oh, sorry. Okay, so 0 plus means it's probably somewhere right around 0. Okay, there we go. So 0 plus means that it's small, but it's possible, but very unlikely. So that's what 0 plus is. So 0 plus would be like an 80% shooter making, something like 30 out of 100. That would be like 0 plus. Okay, so that one went faster. Again, hopefully this helps.